Okay, so quick recap of the things that we were discussing about last time. Okay, so we saw that we define a function as a relationship between two variables, x, which is an independent variable, and let's say another variable y, which we call the dependent variable. So the general way of expressing a function is that the dependent variable is always written on the left hand side, and that is equal to some kind of a relationship with respect to the independent variable, which is written on the right hand side. So the symbolic representation of function is that y is equal to fx, which means the dependent variable y is a function of the independent variable x. So here x and y are just the standard symbols that we use. Now we can always have other symbols in place of x and y. So for example, this represents this relationship that y is a function of x. But similarly, if I write s is equal to f of t, this statement now represents a symbolic representation of the fact that s is a function of t. So in this case, t would be the independent variable. And s would be the dependent variable. So it is just a matter of convention, as I told you, that the dependent variable is written on the left hand side and the independent variable is written in the expression on the right hand side. Okay. This is about a function. Now, functions can be algebraic. Like this is an example of a what we call a linear function. This is a general expression of what is called a quadratic function. Where a, b, and c are constants or any three numbers basically. Okay. Like that, in general, if we have this kind of an expression up to any power, let's say, so this is called a general polynomial function. So this type of function, which is written as a series of powers of x. So there's a constant term, then there's a term with x to the power 1, then there's a next term with x to the power 2, going up to x to the power n. So this is called a general polynomial function, and it is of what we call degree n. So the highest power of x is called the degree of the polynomial. So quadratic function has the highest power of x equal to 2. So it is a polynomial of degree 2. A linear function is a polynomial of degree 1, so on and so forth. So these are some examples of what we call algebraic functions. Okay. Now algebraic functions need not be restricted to only polynomials. Okay. Algebraic functions could have different type of algebraic operations also. Y is equal to square root of x. Okay. Or y is equal to 1 upon x. Or y is a combination of these things. It could be x square plus 1 by x square. So these are all examples of algebraic functions so far, what we say. So they all depend on algebraic operations. Apart from algebraic functions, we can also have things like this. Y is equal to sine of x, or y is equal to cos of x, or y is equal to sine of x plus cos of x, or any such relation, tan of x. So these are all examples of what we call trigonometric functions. Okay. So a couple of new type of examples that we've seen here, and the definition of the polynomial function that we've discussed here. You can just note these things down. Other than that, you already have these in your notes. Okay. Okay, now we will also be learning another couple of new types of functions called exponential function and logarithmic function today. But before that, let's come to the most important thing related to the function, and that is the concept of rate of change that we discussed last time. So rate of change of a function so for any given function y is equal to fx, for example, as you know, we define two types of rate of changes. The first type of rate of change is the very simple one, which is called the average rate of change. So average rate of change क्या होता है? It is rate of change of y with respect to x for a given interval of x. Let's say from x1 to x2. So we have the formula for average rate of change. It is change in y upon change in x for that given interval. So it is nothing but y2 minus y1 upon x2 minus x1. Where further, y2 can be written as f of x2, y1 can be written as f of x1 divided by x2 minus x1. So this becomes a simple formula for the quantity average rate of change. That what is average rate of change in a given interval x1 to x2? It can be calculated by this formula y2 minus y1 upon x2 minus x1, or y2 is nothing but f of x2, y1 is nothing but f of x1. It can be calculated by this particular formula. Okay. So for example, if we have a function, let's say x squared plus 3x plus 2, and we have to find out the average rate of change from x equal to 0 to 2, let's say. Okay. And then again from x equal to 1 to 3. So all we have to do is we have to plug in the function x squared plus 3x plus 2 in this particular formula here. And for the first case, we have to substitute x1 as 0 and x2 as 2. For the second case, we have to substitute x1 as 1 and x2 as 3. Okay. So just work out this question quickly. Yes, you had a doubt? Somebody? Lakshya? Okay. So just work this out and send me the answers, or you can tell me the answer.
सर
Yes.
सर इट इज द फर्स्ट डे सर, वो नेटवर्क का कुछ इशू था, उसमें लेट
Okay,
हो
so
गया।
I will send you the recording and the notes now. You can pick it up from there. Okay, it was anyway revision of what we've done in the last lecture. Okay. This part is clear so far. What you're seeing in front is clear, na? Rate of change में average rate of change का formula क्या होता है? It is y2 minus y1 upon x2 minus x1. So now just apply it to the question that I put up over here. Yes, Arushi, that's correct. Very good. Harsh, Vedant, correct. Very good. Both the parts are correct. Avi, correct. Rishikesh, just check the answer of the first part once. Aditya Joshi, correct. Very good. Shivang, correct. Trai, correct. Okay, so most of you have got this correct. Okay, in fact, almost everyone has got this correct, no problem. So let's just quickly work out. Okay, so for the first part, we'll take x1 as 0, y1, sorry, x2 as 2. So therefore, y1, which is f of x1, will become nothing but 0 square plus 3 into 0 plus 2. So that's 2. And y2, which is f of x2, will become substitute 2 in this formula, because the function here, the function is x square plus 3x plus 2. So 2 square plus 3 into 2 plus 2. So that's how much now? 4 plus 6, 10 plus 2, 12. So now delta y by delta x for this interval becomes y2 minus y1 upon x2 minus y1. So y2 is 12, y1 is 2, x2 is 1 is 0. So as you can see, it becomes 10 by 2 or 5. So that is the average rate of change for this interval. This quantity here, delta y by delta x equal to 5. This is the average rate of change from x equal to 0. Now, same thing you have to repeat for the second part also, but with taking the value of x1 as this time 1. So y1 becomes f of 1. Okay. So that is 1 square plus 3 into 1 plus 2. So that's 1 plus 3 plus 2. So that's 6. Okay. And x2 is 3. So y2 is f of 3. That's 3 square plus 3 into 3 plus 2. So that's 9 plus 9, 18 plus 2, 20. So now you can see that the average rate of change becomes y2 minus y1 upon x2 minus x1, which is 20 minus 6 or 14 divided by 3 minus 1 or 2. So that is 7. Okay. So this is the average rate of change for x equal to 1 to so any doubt in this calculation?
No, sir.
Okay. Right. So that is about average rate of change. Now, moving on from average rate of change, we have the second type of rate of change for which calculus comes into the picture, okay, which is called the instantaneous rate of change. So this is defined as rate of change at an instant. So it means at a certain value, not for an interval, but at a certain value of x. So we have a special symbol for this instantaneous rate of change. That special symbol is dy by dx. Right? Instead of delta y by delta x, you have a special symbol dy by dx. So this is read as the instantaneous rate of change. Of y with respect to x. And this is given by a definition that it is limit delta x tending to 0 of delta y by delta x. That means it is rate of change for an extremely small interval. Or further, this is written as in definition, limit delta x tending to 0, f of x plus delta x minus fx divided by delta x. So this thing is the definition. Although we don't use the definition to calculate rate of change, we use a process called differentiation, which directly gives us this rate of change. So this is the definition of instantaneous rate of change. But instead of using the definition, we use a process called differentiation. So differentiation we can think of as an operation to calculate the instantaneous rate of change dy by dx for a given function y equal to fx. So this is what differentiation does. It's an operation. So the differentiation operator has this symbol. This is the symbol for the operation of differentiation with respect to x. So we can visually understand differentiation like an operator. Where if we input the function y is equal to fx, the output that this operator gives us is dy by dx or instantaneous rate of change. Okay. Okay, so once again, I'm repeating, this is the meaning of the term differentiation, or this is the meaning of the term instantaneous rate of change. But how do we calculate instantaneous rate of change for a given function y equal to fx? We don't sit and derive it from this definition every time. Instead, we apply an operation called differentiation. So differentiation is simply an operation that gives us directly as the output. When we input a function y equal to fx into the differentiation operator, it applies on that function d by dx of fx, and the output of that operation is nothing but the instantaneous rate of change. Now, for giving us this output, we have a whole set of formulae and properties of differentiation that we had started with last time. Okay, and using those formulae and properties, we can calculate the differentiation for any given function. So, for example, we had seen so far in formulae of differentiation, we had seen one important general formula, that differentiation of x to any power becomes n into x to the power n minus 1, where n here could be any real number, negative, positive, greater than 1, less than 1. So this means that, for example, if y is equal to x, then differentiation of y with respect to x is differentiation of x, which is x to the power 1. So it is 1 into x to the power 0, which is 1. If y is equal to x square, for example, we saw that differentiation of y with respect to x is differentiation of x square. So n becomes 2 over here. So it becomes 2 into x to the power 1. So that is 2x. If y is equal to x to the power 4, then this becomes similarly 4x cubed. If y is equal to square root of x, it means that we can write y as x to the power half. So differentiation of x to the power half will become 1 by 2 into the x to the power half minus 1, or 1 by 2 x to the power minus half, which we can further simplify and write as 1 by 2 root x. Okay, so this becomes like this. So these are general examples of how we apply this particular formula. Right from a single linear term or quadratic or power 4 term to anything like this also. Okay, so I had a few examples of this kind of differentiation in the worksheet last time. So hope you tried that out, and we'll discuss some of those examples in a little time. So in the meantime, as you're noting this down, just find dy by dx for the following. Okay, so just find out dy by dx for these three and let me know.
Sir, can you scroll up a little? Sir? Sir,
Yes.
can you scroll up a little?
Sorry, can I scroll?
Scroll up a little.
Scroll up. Okay. So before this formula of this, for the definition of differentiation, is it?
Yes.
Okay. Okay, so this is the symbolic representation of the operator, the differentiation operator. So when we input some function into the differentiation operator, the output that we get is the instantaneous rate of change.
Can you show the question?
Yeah, I'll take you to the question. Just a moment. Huh? Peter, you finished writing this part?
Yes.
Okay. Okay, very good. Arushi, that's correct. Dharmik, that's correct. Harsh, correct. Okay, so I'm just going to work out these questions now. So the first one, for example, difference, we are applying it to 1 by x square. So 1 by x square can be written as x to the power minus 2. So now we'll apply this x to the power n formula in it. So n is minus 2. So it will become n into x to the power n minus 1. So that makes it minus 2x to the power minus 3. Or we can say that it is minus 2 by x cube also. So this becomes dy by dx for y equal to 1 by x square. Okay. So please go over the step-by-step application of differentiation very carefully here. It's just we are applying the formula that differentiation of x to any power is equal to that power n into x to the power n minus 1. We just apply that over here. So please go over the steps carefully and let me know if there's any doubt at all. Very good, Vedant, that's correct. Harsh, correct. So as you can see, it's just a matter of practicing this out. Okay. So y is equal to cube root of x. So that can be also expressed as y is x to the power 1 by 3. So that is the meaning of cube root. Cube root of anything means, so for example, you know that cube root of 8 is equal to 2, or cube root of 1 is equal to 1, or cube root of 1000 is equal to 10. So like that, this is cube root of x. So differentiation of y with respect to x is differentiation of x to the power 1 by 3. So that is 1 by 3 into x to the power 1 by 3 minus 1. So we can write it like this. Or we can also write it like this. X square cube root. So whichever way we want to write it, we can write it like this or like this. Okay. Now the thing is, at JEE level of MCQ questions, you must know how to reduce the answer to some other form. For example, you might have got the answer to this form, okay, this one over here, but this is not matching any of the options because the option has reduced it to this, okay, or maybe the option is given as this. So all of these are correct answers. They are equivalent to each other. So you must know how to convert one to the other. Very good, Ashutosh and Trey, that's correct. So let's come to the third one. Now, third one, before you differentiate, you have to do a further bit of simplification. The third one, y is given as x into square root of x. So this has to be reduced to the form y is equal to x to the single power. So to reduce it to this, we will use the property that x to the power a into x to the power b is equal to x to the power a plus b. Similarly, if we had something like this, x to the power a upon x to the power b, we would have used the property a minus b. Or if we had something like this,
A into B.
So these are some of the properties of indices that we can use in these type of questions. So we can say y is equal to x to the power three by two. So differentiation of y with respect to x, we can now express as differentiation of x to the power 3 by 2. And then we can apply the power rule. So that is 3 by 2 into x to the power 3 by 2 minus 1, or 3 by 2 into x to the power half. So this is also okay, but we can further reduce it and write it as, actually not reduce it, it's just that we are writing x to the power half as root x. Okay, so very good. Many of you got all three questions correct. Ashutosh, Vedant. Okay, so it's just a matter of practicing out these type of questions. Okay, I have given you a few in your worksheet number 2, which I gave last time, and there are also few application type of questions in your module exercise number 1. So after today's lecture, I will also be sending you a list of questions to do from the module exercise. So you can try those out also. So it's just a matter of having the patience to learn how to apply the formula for these different types of questions. Okay. Other than that, this is very easy, this differentiation part. Okay. It's formula based. The important thing is to understand the application and meaning of differentiation. So we'll come back to that also. Slope of tangent and all those things. Okay. But first things first, we have to learn how to apply the formula of differentiation, the formula and properties for different types of functions. Right. So hope this part is clear. Now moving on, we had also seen, so we'll come back to more formula of differentiation today, but we had also seen certain properties of differentiation. Let's do a quick recap of those. So first thing we had seen that differentiation of any constant is equal to 0. E is a constant. Then second thing we had seen that differentiation of any constant multiplied by a function can be written as the constant times differentiation of the function. And third thing we had seen was that differentiation of the sum of two functions is equal to differentiation of the first function plus differentiation of the second function. Or for that matter, if we are subtracting two functions, then it is the difference of the individual differentiations of the two functions. So you can see that along with these properties now, if we use the formula that we have learned, that differentiation of x to the power n is equal to nx to the power n minus 1, then this becomes a very powerful set of formulae and properties through which we can differentiate lots of algebraic type of functions. Okay. So for example, we want to differentiate something like this: y is equal to x square plus 1 upon x. Now this looks like a very complicated, or let's say it's x square plus 2 upon x. Now this looks like a very complicated function, but we can see that if we just reduce it a little using algebra and then properties above, okay, it becomes quite simple really. So first step, we can see that if we can reduce it like this, that x square plus 2 by x can be written as x square by x plus 2 by x. So that is x plus 2 by x. Or we can also write it as x plus 2 into x to the power minus 1. So that we can use this formula now. So now the next thing, differentiation of y with respect to x will become differentiation of this function, but we have reduced it to this. We have reduced it to this now. Okay. So now you can see that it is the sum of two terms, this and this. So we will use this third property over here. Okay. So this will be written as differentiation of the first function x plus differentiation of the second function. Okay. Now further we can see that this here is a constant. So you can bring that outside. Okay. So further this will become differentiation of this plus 2 times differentiation of x to the power minus 1. Now you can see that each of these terms is of this type. So we can use this formula here as well as here. So you know that differentiation of x becomes 1, but differentiation of x to the power minus 1 becomes minus 1 into x to the power minus 2. So finally this differentiation, it becomes 1 minus 2 by x square. This becomes the value of dy by dx. Okay. So just go over the three properties once more, make sure that you have internalized them. Okay. And then see how we have applied it step by step, along with a bit of simplification. We could not directly apply differentiation here. So we had to first simplify this like this, so that it became the sum of two functions rather than one function divided by another. So please go over the steps very carefully, and if there's any doubt whatsoever, please let me know.
Sir, can I ask you a doubt from the worksheet?
Yes, I'm coming. Just let me finish this revision part now, and next
Okay.
after that I'll come to the doubts in the worksheet only. Okay. Right. So hope this example is clear to all. Okay, so let's just do a couple of more examples and then we'll move on to the doubts. Okay. So find dy by dx for okay. So just apply these similar kind of steps. Okay. For example, the first two are very simple. You don't need to simplify. You can directly apply differentiation. The third one is a little bit like the one I've done over here. You have to first simplify this and then apply the differentiation properties and then finally the formula. So after we complete this couple of examples, we'll come back to the worksheets to discuss whatever doubts you have. And then we'll move ahead with additional formulae and concepts today. Yes, Vatsal, we will do the question related to differentiation of quadratic equation also. Okay. Shivang, correct. Manya, correct. Okay, so the moment you apply the differentiation operator, na, Yashovardhan, you will realize how to separate the terms, because you want to write them as individual terms of x to the power n. Na? So you immediately understand how you have to separate them. And Rishikesh, to answer your question, yes, it is necessary to be able to reduce it to the simplest form. The simple reason that, remember that at the JEE level, you are doing MCQ questions. Na? So the options might be given in the simplest form. So you have to reduce it to the simplest form. Na? Otherwise, you will not be able to match it with the options. Following my point now?
Yes, sir.
So now, for example, in the first one, the moment you apply the differentiation operator on the function, so you see the function, now there's no direct formula for differentiation of this. No? So you realize that you have to apply the property. Now, what property to apply? You can see it is the sum of three different terms. So obviously we'll start with the that you can take the operator inside the function, I mean inside the bracket, and just separate it out. Now we can see that this term is a constant. So obviously this term will become 0. Okay. This term is also a constant, but it's multiplied by x. So it will come outside. So 3 times differentiation of x. And this is already in the power form. So we don't need to do anything. Now we apply the product of the power rule. So differentiation of x cube will become 3x square. Differentiation of x is 1. And differentiation of this is 0. So that's it. That's our answer. So we can just about reduce it a little bit further and write it like this. But both of these are correct answers. So this becomes the differentiation. Okay. So just to answer your question, that differentiation of a quadratic function, it would be very similar to how we've done this cubic function. Only instead of power 3, the power would be 2 for the first term. Very good, Avi, that's correct. Harsh, your answer is correct. For all three parts. Okay. Okay, second part is also fairly simple. We just have to do a bit of simplification. So y is equal to x root x plus 2x plus 1 by x. So when we apply the differentiation operator, you can see that first separate it out like this. Then we can simplify the first term a little bit before we differentiate. So x into root x, as we have seen before, is
X to the power 3 by 2.
Yes, very good. That's x to the power 3 by 2, right? So after a while, it just becomes, like your matching patterns. You have seen this differentiation before in another question, and now you have to just apply that same concept here, but as part of this question. So this will become 3 by 2 root x. This will become 2, and this will become minus 1 by x square. You can write this as 3 by 2 root x plus 2 minus 1 by x square. So the thing is, see, whether we write the answer this way or this way, it's correct. There's nothing wrong with either of the two. But it's just that sometimes in an MCQ question, the option is given in a different way. Like, for example, here we can actually take LCM and we can reduce it to this. We take 2x square as the LCM. So this will become 3x square root x, right? Plus 4x square minus 1. So the answer might be given in this form. Okay, so you have to know how to reduce it from this to this. Yes.
-2.
-2.
Which one?
The third one.
Sir,
Third term.
Oh,
the
sorry.
last
Yeah,
term
yeah,
-2.
yeah, correct. The last term here should be -2, correct. Okay. So the thing is that we have to be able to reduce it without making the type of mistake I just made. That so that you don't. Okay, so having gone through the properties and formulae of differentiation so far, okay, let's quickly also reinterpret that what is the meaning of differentiation or what is the meaning of rate of change. So geometrical interpretation of rate of change.
So,
Yes.
so there was only third sub part that x cube.
Oh, yes. I'll do that also. I'll come to that. Just give me a moment. So the third sum we have to first reduce. We'll do this, then we'll get back to geometrical interpretation. Just a moment. Okay, so let's come to this. So first what we'll have to do is we'll have to reduce this. So x cube upon root x plus x square upon root x plus 2x upon root x. So this will become x to the power 3 minus half. So that will become 5 by 2. Okay. This will become x to the power 2 minus half. So 3 by 2 plus x to the power 1 minus half. So, okay. So hope this step is clear to all of you, this one.
Yes, sir.
Okay. So now you can see that once you've reduced y like this, so it's easy to apply the differentiation operator. So this massive looking thing is somewhat reduced in the first step itself. And second step, when we take the differentiation operator inside and use the distributive property, right? So it becomes quite simple. And then take the 2 also outside because it's a constant. And then just apply the power rule. So this becomes 5 by 2 x to the power 3 by 2 plus 3 by 2 x to the power half plus 2 into half x to the power minus half. And then again, it's a matter of how we want to simplify and write it. Okay. We can write this like this also, for example. Or if we want, we can take LCM once more and simplify it and write it as 5x cube, right, plus 3x plus 2, whole thing divided by 2 root x also. So if we are doing the question the way we are doing as a subjective question, then it's up to us. We can leave the answer at any of the stages. Okay, because after this step, the differentiation is done. Okay, so this answer is also correct on its own. Nothing wrong with this. This is also correct answer. This answer is also correct. But this is after the maximum simplification. So typically in an MCQ question, the option will be given after simplifying to the largest extent. The answer might be most probably given in the last form that I've shown. So you have to know how to reduce it from here to here. Okay. And that's just a matter of simple algebra. There's nothing new in that as far as differentiation is concerned. Okay, so now coming back to that geometrical interpretation, let's look at that quickly. So given the graph of a function, what is the difference between average rate of change and instantaneous rate of change? In terms of the graph, what it means. So let's discuss that next. Suppose my given function has this sort of a graph. So this is the graph of y equal to fx. And in this graph, I want to now find out the average rate of change from, let's say, x equal to a to x equal to b, or x1 to x2, whatever, where I know that a is the point here and b is the point here. B is this point. Okay. So I know that from formula delta y by delta x will become f at b minus f at a divided by b minus a. Or basically what was y2 minus y1 upon x2 minus x1. Where here I've taken b as x2 and a as x1. Okay. But in terms of graph, what is this quantity? Let's understand. So if this point on the x-axis is a, then the corresponding point, which is the y coordinate on this graph, is nothing but f of a. Or basically this is my x1, so this is correspondingly my y1. Similarly, if this point on the graph has an x coordinate of b, then its y coordinate is nothing but the value of the function at the point b. So if this is x2, then this corresponding point is y2, which is the value of the function at b. Okay. So now you can see that the rate of change is the difference of these two quantities, y2 minus y1, divided by the difference of these two quantities. So over here, this is my x2 minus x1, which in this case is equal to b minus a. And this quantity in the numerator, y2 minus y1, that is this over here. This is my y2 minus y1. In this case, it is f of b minus f of a. Okay. So you can see that if you just extend this here, this is my delta y, or y2 minus y1. And this is my delta x. So the geometrical meaning of this average rate of change thing becomes just the ratio of this distance here to this distance here. So the ratio of these two distances is nothing but the slope of this type of line. So this type of line, as you know, we call it the secant line. Okay, this was given a special name that when we join 2 points on a graph, x1, y1 and x2, y2 as a straight line, then that line is called a secant line. Okay, so the slope of the secant line joining the 2 points, in this case at x equal to a and x equal to b, that's slope. And what is the meaning of slope? It is nothing but tan theta. So this is our secant line, and this angle over here is theta, or whatever angle this secant line will make with the x-axis below here, that is our theta. So this also becomes equal to tan theta. So it is the slope of secant line joining on the graph. So this was the geometrical interpretation of average rate of change. So this is very important to keep in mind what it means, not just that we should be able to calculate what is required, but what is the meaning of that calculation, okay, how to interpret it. So one of the ways to interpret average rate of change is geometrically from the graph, and that is nothing but it is the slope of the secant line. Okay, so any doubt related to this?
No, sir.
No,
Is
sir.
clear now? Okay, so
Yes, sir.
now on the other hand, the interpretation of instantaneous rate of change becomes more interesting, because we have to interpretation. So for a function y is equal to fx, instantaneous rate of change is defined as limit delta x tending to 0, delta y by delta x. Or further, we can define delta y as the change in the value of the function as we go from x to x plus delta x. So this quantity, let's interpret in terms of the graph. Okay. So once again, now suppose I want to find the instantaneous rate of change at this particular point. I want to find dy by dx at that particular x. I could write this as x1 also, but I'm just writing it as x. Okay. So what we have to understand is that at this point, okay, the value of the function is this one. So this is our fx. Okay. But now if I go to the meaning of this term, which I've written on top, it is the change in x, sorry, the change in the y coordinate divided by the change in the x coordinate, but I'm changing the x coordinate by a very, very small quantity, delta x tending to 0. So how I'll interpret that in terms of graph is that I should move from this point to a point which is very, very close to this one. So literally I have to zoom into this graph as much as I can. I have to zoom into this graph as much as I can, and then try and draw a point which is right next to this one, so that the distance between these 2 points becomes negligible. So then this distance which is there between these 2 points, this is my dx, which is basically delta x tending to 0. That is the meaning of dx. And correspondingly, when I select that point, I'll get some very small change in the y coordinate also. And that change in the y coordinate is my d1. So the ratio of these two becomes my instantaneous rate of change. So now if I join these 2 points with a straight line, the type of straight line I'll get is called the tangent line at that point. Because when I zoom out of the graph, it will look like this line is not passing through 2 different points, but it is actually passing through the same point merged. So this type of line now is called the tangent line. And this becomes nothing but the slope of the tangent line.
So, but this you are doing on the computer, but in real life, how can we do this?
Exactly the point. So that is the whole idea. In real life, we cannot do this on pen and paper, right? So that is why we need a different type of maths to do the calculation of this. So what is the maths to do the calculation of this? It is the differentiation. You understanding?
Yes, sir. Okay.
So we should know the formula of this function. Without knowing the formula of this function, with the graph alone, there's no way I can find the slope of the tangent. But if I gave you the formula of the function, like I gave you so many examples, like, so if this is, let's say, a cubic function or something, then you can differentiate it. Okay. And when you differentiate it, if I ask you to find the slope of the tangent at some particular point, you can substitute the value of x for the rate of change at that point and find the slope of the tangent. Got it now?
Yes, sir.
Okay. So now if I put this under a magnifier, okay, so what you are actually seeing under the magnifier is that okay, let's say this is how the function is going at that point, okay, and this is the point x equal to x, and this is the corresponding value is fx. Okay. But now this is the point x plus delta x, but of course we are making this delta x tending to 0, so it becomes so this point on the y coordinate will become f of x plus delta x. So this difference between these two is your delta y tending to 0 or dy. Okay. And now the line joining these 2 points, that is your tangent line. So the slope of the tangent line, so this becomes tan theta or slope of tangent. Okay. So that is why we say that geometrically speaking, this is quite an abstract definition. Abstract ka matlab kya hai? Something that we can imagine, okay, but something that does not directly give us a formula or method, something that is left to our imagination, that is called abstract. So for example, in maths, you can say the concept of infinity itself is quite abstract because we cannot exactly define infinity. We can just have an idea about it, that infinity is such a large number that it cannot be compared to any finite number. Okay, so that is why infinity plus any finite number is still infinity. Infinity minus any finite number is still infinity, because it's such a large number that it cannot be compared with any other number. So like that over here, this is an abstract concept, like you yourself pointed out, that I'm just showing it like an example, and that too using a computer graphics screen. Okay? But even in my graphics screen, it's not like it's accurate or anything. It's just a way of explaining it. So given a function, how will I actually calculate the slope of the tangent? I have to rely on the algebraic method, which is called the differentiation. Right. So hope this point is clear to all of you. Yes.
So, sir, slope will be basically calculated from differentiation, and
Yes.
for average, it will be from y2 minus I divided by
For average, we directly have that 2 minus y1 upon x2 minus x1. Whereas for slope of tangent, we have to calculate the slope using which formula? The differentiation formula. So differentiation formula is different for each and every function. No? So there's no one common formula, right? We have to apply the operator of
Yes, sir.
differentiation. Got the idea, no?
Yes, sir.
Okay, so let's understand this with a numerical example. So last time you'll remember we had discussed a little bit about the graph of x square, the function y equal to x square. So let's go back to that graph and let's see how the slope of tangent looks at various different points. So I have the graph of the function y is equal to x square. Okay. So as you know, this at the value x equal to 1, the value of y will be 1. But by the time x becomes 2, the value of y becomes 4. So it rises quite rapidly. By the time x becomes 3, the value of y has increased to 9. My graph is not exactly drawn to scale, but you can still understand from it. Okay. So by the time x is 4, y has risen more sharply to 16. Now, if I ask you find the slope of the tangent. Okay. At x equal to 1, x equal to 2, and x equal to 3. Okay. So this becomes like a further application of differentiation. What do we mean by slope of tangent? So slope of tangent is equal to the instantaneous rate of change. Okay, so it is nothing but dy by dx. Okay, so therefore at x equal to, so for example, the first part at x equal to 1, okay, slope of tangent will be equal to the value of dy by dx at x equal to 1. So what do I mean by this? So see, now my function is what? My function is y is equal to x square. This function is y is equal to x square. So what is the differentiation of the function? It is 2x. So what is the meaning of this? That at any point x equal to x, the rate of change, the instantaneous rate of change, its value equal to how much? Is equal to 2x. So what is this instantaneous rate of change? This only is slope of tangent. But at which point? At a general point x equal to x. So at a specific point now x equal to 1, what it will be? It will be the value of dy by dx, 2x only, but at a specific point x equal to 1. So that will be how much? 2. So that means now at this point x equal to 1 over here on the graph, if I draw a tangent line, so roughly speaking, this is the tangent. So this tangent should have a slope of how much? It should have a slope equal to 2. That is what the formula is showing.
Sir,
Is it? Yes.
sir, I did not understand from the part where you said at any point x is equal to x, instant rate of change is equal to 2x.
That is the differentiation, na, beta. If y is equal to x square, what does differentiation of x square give me? It gives me 2x.
Right.
So 2x basically kya hai? At a particular point x equal to x, 2 times the value of x is basically what? It is the instantaneous rate of change.
Oh, okay, okay.
So now if I say, okay, that point is x equal to 1. So on that point on the graph, what is the instantaneous rate of change? It will be 2 times the x coordinate. So that is 2 times 1. Okay, so that will be 2.
Oh, okay, got it.
Okay, but for example, if I come to the C part directly now, at x equal to 3, what will be the slope of tangent? It will be the value of dy by dx, but specifically at which point now? X equal to 3. So it should be how much?
6.
It should be, yes. So you can see, now in the graph, you can see that the point 3 is such that when I draw tangent at this point, the shape of the graph you can see is such that slope iska zyada ho gaya. It's a much steeper slope.
Yes, sir.
Okay, so even without doing this calculation, I could have told you one thing by looking at the graph, that if I draw the slope, if I draw the tangent at the point 3, it should have a much larger slope than the tangent at 1. But now differentiation is telling me what? Numerically, kitna hai wo slope. It's not just telling me ki it's more here or less over there. It's telling me that at 1, the slope is exactly equal to 2. It's telling me that at x equal to 3, the slope is exactly equal to how much? It's equal to 6. Okay, so this point on the graph is equal to 3,9. Okay, so at that point 3,9, if I draw a tangent line, it's telling me the slope of that tangent line should be how much? It should be equal to 6. So like that, if I draw tangent at any point x comma y for this graph now, okay, for y equal to x squared. So what is the slope of the tangent? In general, it is equal to 2x. So in particular, if x is equal to 2, the slope of the tangent is 4. If x is equal to 3, the slope of the tangent is 6. If x is equal to 100, the slope of the tangent has become 20. Sorry, 200, right?
Yes, sir.
Okay, so that is the meaning of slope of tangent through instantaneous rate of change. Okay, people, so hope this point is clear to all of you.
Yes, sir.
Okay.
Yes, sir.
Okay, so you can just go through this once, and in the meantime, if you have any doubt from the first worksheet, okay, let me know about that first. Okay, I have sent you hints and answers for the first worksheet, but if you have any doubt in spite of going through the hints and answer key, please let me know and we will discuss that first. Okay, so next
I
week,
have a doubt.
yeah, tell me.
So in first question, that
Of worksheet 1, okay, I'll
Yeah.
explain that. So after this, we are coming to
In fact, so first and second, and so third question, sorry, fourth question, the third and the second subpart.
okay, okay. Okay, so I'll go systematically. Let's start with the first question. Okay. So this part is clear to all of you?
Yes, sir.
Okay, okay. So just give me a minute. I'll share the worksheet document, okay, so that we can go through the questions.
Sir, in our major test, which will be held next week,
Yes,
only
yes.
this part will come, right?
Only differentiation and I mean only rate of change concept of functions, what we have learned till today. Okay.
Okay,
So
sir. Thank you.
average rate of change of function, differentiation of function to calculate instantaneous rate of change, and properties of differentiation.
Okay, sir.
Okay, so let's go through the first question once more. Okay. Now remember, at this stage we had not learned differentiation. Now this was like 2 weeks back. So at that stage we had not learned differentiation. So all these questions there, you can solve them without using differentiation. You can just solve them using the basic concepts of slope of a straight lines, you know, y2 minus y1 upon x2 minus x1, those kind of concepts only. Okay, so we'll discuss in a moment. So just go through and explain. Okay, so what is happening here? Yashovardhan, to answer your question, you don't have to plot any graphs and all that in the exam, but interpretation from a graph can come. Like in this worksheet only, I have given you an example which has a graph now, and from the graph you have to calculate average rate of change. So that kind of question can come definitely. Okay. So now let's see what information is given to us. So it starts from rest at t equal to 0. That means we can take the initial velocity of the particle as 0 at t equal to 0. Then what is happening? From 0 to 10 seconds, it has a uniform, the speed is increasing at a uniform rate. Okay, so from 0 to 10 seconds, we can say that the speed is increasing, that means acceleration, and acceleration is uniform, so it's equal to how much? Plus 2 meters per second square. Or we can say that delta v by delta t is equal to plus 2 meters per second square. And then after that, what is happening? It's saying that thereafter it decreases at a uniform rate. So when time becomes greater than 10 seconds, the acceleration will change to a deceleration. So it will become minus. Okay. Or we can say that delta V by delta T will become minus 4 meters per second square till it stops. So now from that, we have to plot the approximate distance time graph. We have to calculate the total time taken for the motion. How much is the average speed for the entire journey? Average speed in the first 10 seconds, last 10 seconds, instantaneous speed at 2 and instantaneous speed at 12. So let's see all this. Okay. So now I'm switching back to my whiteboard. Okay. So putting together the information that we had over there, let's start with the graph. How does the distance versus time graph look like? So we want to plot the distance versus time graph. So let's say this is our distance, this is our time axis. That's in meters versus time in seconds. Okay. So from 0 to 10 seconds, okay, our initial velocity was 0, but our acceleration was plus 2 meters per second square. So what will our distance versus time graph look like? Should it look like a straight line or should it look like a curve? So what is happening to speed? It should be curved, no? Because speed at a general time t less than 10 seconds, that's a variable quantity. No? V will be equal to 80 over here because u is 0. So V is equal to 2t. Okay. So that means the slope of S versus T, it should be an increasing quantity. No? Okay. So that means it should be like this. Be curving like this because the slope is changing. Should be like this. Okay. Till we reach 10 seconds. And then after that, what should happen? It should be a decreasing slope. So we'll calculate whatever this distance is. Okay. Now after 10 seconds, what is happening? For t greater than 10 seconds, the acceleration is now negative. It's decelerating. So what is happening to the speed? The speed is decreasing with respect to time. Okay. So that means the slope of S versus T graph should be decreasing. So if the slope is decreasing, then now in the second part of the graph, how the curve should look like? It should look like a curve which is having a decreasing slope. It should look like this. Till the slope becomes almost 0 at some particular time. That time we'll figure out how much that is. It becomes almost a flat line. So we'll figure out all this. Okay. Now what else we can, apart from distance time graph, we can also interpret this in terms of a speed versus time graph. So instead of looking at the distance versus time graph, if we visualize the speed versus time graph, that's going to be something easier because what is happening? Speed is a linear function of time. So if I interpret the speed versus time graph here, I can see that in the first part, the speed is increasing uniformly with time till 10 seconds. And it's increasing at the rate of 2 meters per second square. So in this interval from 0 to 10 seconds, I have an acceleration of plus 2 and the initial velocity was 0. So how the speed versus time graph will look? It will look like a straight line, right?
Yes, sir.
So speed should increase uniformly at the rate of a equal to plus 2. So at 10 seconds, how much the speed should become? It should become 2 into 10, that's 20.
Yes, sir.
Okay. And after that, what is happening? From 10 seconds onwards, it's having a deceleration of -4 meters per second square. Okay. So then how should this graph look like? It should look like a straight line with a negative slope. Should look like a straight line with a negative slope.
Yes, sir.
Right. So this is -4 meters per second square. Now, can you tell me how much this time is? Okay.
5 seconds.
Because yes, very good. It's 5 seconds. You know, because at t equal to 10 seconds, what is the speed? It is equal to 20 meters per second. That we saw from the first part of the graph. Okay. Because u was 0, so at 10 seconds. Okay. Now, at let's say t equal to t1, the speed should become 0. So what is the time interval from this to this? The time interval delta t is t1 minus 10. And in that time interval, what should be my delta v by delta t? It should be minus 20 divided by whatever this time interval is. So that is equal to how much? -4, because the rate of deceleration is -4. Delta v by delta t is equal to a, which is -4. So this is telling me that per second, the speed is reducing by 4 meters per second. So how many seconds it will take to reduce from 20 to 10? It will take 5 seconds. So that means this minus delta t, this delta t is basically equal to how much? It's equal to 5 seconds. So delta t is equal to 5 seconds. So in other words, t1 is equal to 15 seconds. So that means this time over here is how much? It's 15 seconds. So that's answering that part, that how much the total time of the journey is. It is 15 seconds.
Okay, sir.
What did you know? So now, for example, so first thing was the graph. So we got that. Okay, then calculate the total time of motion till it stops. That's 15 seconds we got now. Okay, now how much is the average speed for the entire journey? So entire journey मतलब क्या हो गया? अभी 15 seconds हो गया. So 15 seconds में मैं average speed कैसे निकालूंगा? Average speed is total distance upon total time.
Yes, sir.
Okay, now can you tell me what should be the easiest way of getting the total distance? From everything I've done on the board, what is the easiest way you can think of calculating the total distance in 15 seconds? How do you get?
Sir, using
Yeah.
the second equation of kinematics.
Okay, that is one option we can use. Okay, but उसमें भी दो बार use करना पड़ेगा ना, because 0 to 10 seconds A is something different, 10 to 15 it is something different, right? Can you tell me a one step solution for total distance? I'll give you a hint. Speed versus time graph से distance कैसे आता है?
Slope.
एरिया निकालते हैं.
Area, very good, very good. Okay, so the C part of the question, I want to calculate the average speed from 0 to 15 seconds. Okay, so for that, what I need the distance from 0 to 15 seconds divided by the time interval. ये निकालना है मुझे. So this distance will be what? It will be the area. It is area under the speed versus time graph. This concept all of you are familiar with, right?
Yes, sir.
So area निकालो, इसका कितना है? Tell me how much is the area of this triangle, this whole triangle? Base is how much? 15 seconds, right? And height
Half
is how
into
much?
15 into 20.
Yes, height is 20 meters per
300.
second. Okay. So half into 15 into 20. So that will give me how much?
150.
The
Meters.
unit will be what? Seconds into meters per second. So it will be 150 meters. Okay. So this will become, so this area is equal to half into base into height. So that is 15 seconds into 20 meters per second. So 150 meters. So my average speed will become meters per second. So this is the easiest way. Now another way we can do is we can calculate the total distance by formula. Also calculate this by formula. The distance from 0 to 15 seconds, we can write as S1, that is from 0 to 10 seconds, plus S2, that is from 10 to 15 seconds. Now for S1, we can use this relation that initial velocity was 0, final velocity is 20 meters per second, and the acceleration is plus 2. So you can use the relation that V square is equal to U square plus 2AS. So from this, we can get S1 as 20 square divided by 2 into 2. So that is 20 square divided by 4. So that's 100 meters. Okay. And then for S2, that is 10 to 15 seconds. The initial velocity is how much? 20 meters per second. The final velocity is 0, but the acceleration is how much? Minus 4. So we can use this relation again, that V square is equal to U square plus 2AS. So this time this is 0. This is 20 square, but this is 2 into minus 4 into S2. So our S2 will come out to be 20 square divided by 8. So that will become 50 meters. So then we can see that, okay, the total distance traveled is S1 plus S2. So it's 100 plus 50. So it's 150 meters. Okay. So this is another method that we can use to calculate the total distance. But as you can see, if I have taken the trouble to draw the speed versus time graph, then it makes it much simpler to do something like this, because we can get it directly from the area under the graph. Okay, so this was not really calculus so much. Okay, this was really concepts from your 9th, 10th kinematics that we are doing a revision of in this worksheet. But through that only we are getting more familiar with the concept of rate of change. That speed is rate of distance with respect to time. So average speed is average rate of change of distance with time. Instantaneous speed is instantaneous rate of change of distance with time. Okay, so this question is clear?
Yes, sir.
Okay, now I'm going to do one of the other parts of this, which is the more tricky one. That is how much is the average speed for the last 10 seconds. Okay, so to do this part, we have to actually understand what is the last 10 seconds. So the total time of the journey was 15 seconds. So what is the last 10 seconds? It's 5 to 15.
5 to 15 seconds.
So what we have to do is we have to calculate the distance traveled from 5 seconds to 15 seconds, from t equal to 5 to t equal to 15. And then we have to divide that with a time interval, which is nothing but 10 seconds, right? So this is the E part of the question, where I want to calculate the average speed in the last 10 seconds. So first of all, we understand what is the last 10 seconds. It is from t equal to 5 seconds to t equal to 15 seconds. So in terms of the graph, 5 seconds is somewhere over here. Okay. So from here to here, I want to calculate the distance. So if I want to go by graph method, I have to basically calculate this total area. This area is equal to the distance from 5 to 15 seconds. Correct?
Yes.
Okay, now if I want to calculate this area, I'll need to know the height of this point, the distance. Okay. So for that, you can see that 5 is exactly the midpoint of 10.
Yes, so it will be 10.
From 0 to 10. Yes, so this speed will be 10 meters per second. Okay. So now we can divide this into two parts. It's the area of this trapezium, this one.
Yes.
ये area हो जाएगा. Okay, this one plus the area of this triangle. Okay, so this is the area of from 5 to 10 seconds plus the area from 10 to 15 seconds. So area from 5 to 10, we'll have to use the trapezium formula. So that is half sum of parallel sides
into height.
So yeah, so sum of parallel sides will be 10 plus, sorry, 20, by mistake, not 15.
Into 5.
Okay. into the perpendicular distance between them, which will be 5 seconds. So that trapezium that I've drawn is like this. This is 10. This is 20. And this is 5 seconds.
So is the total 120?
Yeah, I'll just verify it for you. So how much this is coming out to be now?
75.
75.
75. Okay. And then this one is area of the triangle.
Half into base into height. So half into 5 into 20.
Very good. Half into base
125.
into
So
20.
125. So this will come 50.
Yes. Okay. So this is coming out 75 plus, how much is it? 50. So 125 meters. Okay. So now the average speed will be 125 meters divided by 10 seconds. So 12.5. Okay. Or you always have the formula based method also. If you want to go by the formula based method, your S1 would be coming from this formula, that 20 square minus 10 square upon 2 into 2. So you'll see that this only will come out to be that area that we got, 75 meters. And S2 would be equal to 0 square minus 20 square divided by 2 into minus 4. So that is 50. So this is the formula based method for calculating distance, where this distance corresponds to this area. Okay. And this distance corresponds to this area.
So the -4 is the acceleration after 20 meters per second, right?
Yes. Okay, it speeds up to 20 meters per second in 10 seconds. And it rapidly decelerates from 20 to 0 in the next 5 seconds, because the deceleration is double. It's 4 meters per second square.
Yes, sir.
Right. Achha, now the question is also asked you to find instantaneous speed, for example, at 2 seconds, then at 12 seconds. You can see that if your graph is a straight line in any interval, then the slope of the straight line is the same thing as the instantaneous rate of change or average rate of change. Both are same.
Yes, sir.
So any instant of time less than 10 seconds, the instantaneous speed will be what? It will be the slope of this. I mean, it will be the value of velocity that you get from this. So for example, if I ask you what is the speed, instantaneous speed at 2 seconds, so all you have to do is
4
use
meters per second.
it will become 4 meters per second. You can use this equation, that v is equal to u plus at for that. Whereas after this, for example, if I've asked you at 12 seconds, now you can see that at 10 seconds it was 20, and after that it's reducing at the rate of 4 every 1 second. So 12 seconds में कितना reduce हो जाएगा? It will become 20 minus 8 or 12 meters per second हो जाएगा. Right?
Yes, sir.
Basically, you can make use of this graph again. So the interesting thing about the question is that the first part of the question asked you to find distance versus time graph, but second, third, and all these parts, the distance versus time graph doesn't really come of much use. What comes of use is the speed versus time graph. So if you have drawn the speed versus time graph yourself, then you can avoid all the formula things and all that, and you can directly get the answers from the graph. Okay, hope this is clear, people.
Yes, sir.
Okay. Yes, Shivang, that is correct. Shivang just mentioned one thing, that to calculate the distance from 5 to 15 seconds, we can do one more thing. We have got the total distance from 0 to 15. So from that, we can subtract the distance from 0 to 5. So that's a much easier method. The total distance we saw was 150 earlier. No? Now, usme se we have to just subtract this triangle from 0 to 5. So the triangle from 0 to 5, you can see is very simple. It is half into 5 into 10. So it's 25. So this area which I've calculated is actually 150 minus 25 by that method. So that's another option we have. So that's in fact a little bit easier because it's a one-step option, right? Okay, now I'm moving back to the worksheet. Okay, second question. Somebody had a doubt in some part in this? Yes. Okay, so this is now just an example where we are using a different physics parameter rather than speed and distance and time and all that to understand rate of change. So what is happening? We have an open cylindrical tank. Okay, so let's say this is our tank. Initially it is empty. So the volume at T equal to 0, the volume of liquid, let's say V naught is 0, but it has a base area of 50 centimeters square. Now what we do is, initially the tank is empty and an inlet tap is opened to fill water at a uniform rate of this much. Now you see this rate is given in what form? It is given in cc per second, cubic centimeters per second. So it's a volume rate.
Yes, sir.
And it's a uniform volume rate. That means if I calculate how the total volume will be changing with respect to time, it should be what kind of graph? It should be a straight line.
Straight line.
So for example, in some time t, the volume should become 4t, right? If this is in seconds and this is in cc, this is how the volume is changing with respect to time. Okay. So let's say after some time, now at t equal to t, the volume of liquid, this would have become 4t in cubic centimeters or centimeter cube. Okay, but this is happening up to what? Up to 2 minutes. Okay. And then after that, what is happening? The base develops a leakage of 8 centimeter cube per second. Okay. With the inlet tap still open. Okay. So inlet is still letting in water at 4 cc per second, but there's a leakage of 8 cc per second. So after 2 minutes, will the level of water continue to rise or will it start to drop?
It will drop.
It will start to drop. No, because the leakage is at a faster rate compared to the inlet, right? So let's just switch to the whiteboard. So what all we have to calculate? We have to calculate the rate at which the level of water is changing after 1 minute. Okay. Same thing after 1.5 minutes. And we have to calculate the average rate of change from 60 to 150. Okay. So this is my vessel, which has a base area of 50 centimeters square. Okay. And it has an inlet tap. Okay. So t equal to 0, it's completely empty. Okay. But we start pouring water at a uniform rate of 4 cc per second. Okay. So for any time less than 2 minutes, what is happening? The level of water would be rising because only inlet is happening. Okay. So the volume of water would be equal to 4t. Okay. In this, but t should be in seconds in this formula, okay, not in minutes. And the rate at which the volume is changing. So I will not write dv by dt because at this stage we have not done calculus. Okay. So we'll write it as delta v by delta t. So delta v by delta t is equal to plus 4 cubic centimeters per second. So the volume is rising. What can I say about this height? Let's say this height is x. X should also be rising.
Yes, sir.
So the volume of water in the tank, we can write as area into x. Okay. So rate of change of volume with respect to time will become area into rate of change of x with respect to time. Right now? So this volume rate was 4 centimeter cube per second. This area was 50 centimeters square. So what is delta x by delta t? So delta x by delta t becomes 4 divided by 50. So that is 0.08 centimeters per second. So the height increases at this rate. Okay, is this point clear to all of you?
Yes, sir.
Okay, so if I think of a x versus t graph, what is happening for the first 120 seconds or 2 minutes? The height is increasing at this rate. Okay. So how much it will become after 2 minutes? It will become 120 multiplied by 0.08. Okay. So that will become 9.6, is it? Okay. Or similarly, if I think of a volume versus time graph, that will also have a similar shape. It will be a straight line, but the volume would have increased to that will also be a straight line. But at 120 seconds, the volume would have increased to 120 into 4. So 480 cc cubic centimeters. Right. Now, after t equal to 2 minutes, what's happening? There is a leakage from the bottom. So this is at a rate of 8 cc per second. But water continues to come down. I mean, continues to inlet at a rate of 4 cc per second. So now what is happening? The level of water, it will start going down. Okay. So now at this point of time, for t greater than 2 minutes, the rate of change of volume, delta V by delta t, will become what? -8 because of the leakage, plus 4 because of the inlet. So the net rate is -8 cubic centimeters per second.
4.
Oh, sorry, -4. Yeah. So the net rate is -4. So if it is reducing at the rate of 4 cc per second, then how much time it will take for the volume to become 0? It will take the same amount of time, another 120 seconds.
Yes.
So this should be a symmetrical straight line. So this should also be a symmetrical straight line. Okay. So this will also tell me that delta x by delta t will become area in 1 upon area into delta v by delta t. So this will become -0.08 centimeters per second. So this was at a rate of plus 0.08. This is now at a rate of minus 0.08. Got it and understood this?
Yes, sir.
Okay. Now, for example, let's pick up one of the questions. So height and all that you know how to calculate. This is all done. Okay. What is the average rate of change of volume from 60 to 150 seconds? Okay. So let's pick up that part. We want to calculate the average rate of change of volume, delta V by delta t, from t equal to 60 to 150 seconds. So it's like we can take t1 as 60 seconds. Okay, so that is somewhere over here. So at that stage, the volume is some V1. We'll find out how much this V1 is. Okay. Then we'll take T2 as 120 seconds. So that is, 150 seconds. So we'll find out some V2. Okay. And then what is this average rate of change going to become? Delta V by delta T will become V2 minus V1 upon T2 minus T1. Understood now how we are relating the average rate of change formula over here, right?
Yes, sir.
Okay. Now how will I find the V1 and V2? I can make use of ratio and proportion in the graph again. It's a straight line graph, right?
Yes.
So देखो, from 0 to 120, the volume has increased at the rate of 4 cc per second. Na? So at 60 seconds, how much will the volume
240.
become?
240
Yes, it will be 240
cc.
cc. Okay, and then 150 seconds is somewhere here. Okay, so at 150 seconds, what should the volume become? So after 480,
360.
very good. So what is happening here? The rate of change of volume is -4. Na? So per second, it is reducing at 4 cc. So from 120 to 150, how many seconds is there? 30 seconds. Okay, so the change in volume will be 34. So 120 cc. So it is reduced by 120. So from 480 to reduce by this thing. So V2 will become how much? 480 minus 120 or 360. So that's how we calculate these two now. So now we have to just substitute these in the formula. So our final volume at 150 seconds is 360 cc. Initial volume at 60 seconds was 240 divided by the time interval, which is 90 seconds, right? This is our average rate of change. So understood now how we correlate the average rate of change formula, which we've seen also today in functions and graphs and all that, with respect to practical problems like this. Okay, people, hope this question is clear.
Yes, sir.
Okay,
Yes,
very
sir.
good. Okay. Come back to the worksheet. Okay, so question number 3 is clear.
Yes, sir.
So you have to directly apply the formula. Okay, and like even the third part, now what is the instantaneous rate of change, but taking delta x as 0.01. So this is not the differentiation method yet. Okay, this is the method where we are taking a small value of delta x. But now you can check the value that you get instantaneous rate of change by taking delta x equal to 0.01. You can check the value that you get now against the differentiation value, that because you've now learned differentiation. So you'll see that it's accurate, but it's not 100% accurate. You understanding my point?
Yes, sir.
Okay. Now what about the fourth question?
Sir, in fourth
Yes.
question, I had only doubted the B sub part. Is the motion accelerated in intervals?
Ha.
Specify. So will it not be 0 to 20, only 0 to 10?
So that is the thing. So see, when you isolate this graph now, between 10 and 20, what does the graph of S versus T look like? Does it look like a straight line to you?
Yes.
It is a straight line, huh?
Yes.
So that means what is the velocity, for example, at this point? It is slope of the tangent. What is the velocity at this point? It's again slope of the tangent. So it's uniform, no?
Okay.
Okay. So what we'll have to understand here is that from t equal to 10 to 20 seconds, okay, the slope of S versus T is uniform. So that means what is uniform? That means speed is uniform. So that means acceleration is what? 0. Okay. But if you look at this interval from 0 to 10, you draw tangent here, you draw tangent here, you draw tangent here. The slope is always increasing.
Yes, sir.
Okay. Or even without drawing a tangent, you can just see that if you draw equal intervals of time like this. Now in those equal intervals of time, is it covering equal intervals of distance? No. You can see that these intervals are increasing, right?
Yes.
So 0 to 10 in this part, it is having increasing speed. Okay. Whereas immediately like that only, if you see from 20 to 30, the slope is decreasing. Or if you draw equal intervals of time, you will see the distances covered are becoming lesser and lesser.
Yes, sir.
Right. So in this interval, it is having a deceleration.
Yes.
Okay. And after 30, you can see the distance is not changing only. So it's not moving at all. So it comes to rest in this part. From here onwards, it's at rest. Okay, so this is clear now?
Yes, sir.
Okay. Okay, people. So make sure you go through the assignment, like the worksheet number 2, carefully again this week. I'll be sending you this thing, an answer key and a set of hints for that also. Okay, and make sure you practice the application of all the formulae and the properties that we have learned so far in differentiation. Okay, so that's your homework for this particular week. And as long as you practice these things, I don't think you'll have any difficulty with the test coming up on Sunday. It will be an easy, simple enough test. There will be half the questions in physics will be from calculus and half will be from vectors. So give equal weightage to both of them while preparing. Okay. So all the best. That's it for today, people. If you have any doubts in between, you can always WhatsApp me also. Yes, I will text the homework in the group also. Don't worry. Okay. So yes.
How many question test?
Sorry.
How many question tests?
There will be like 25 questions per subject. So 3-hour test. Okay, 25 questions in physics, 25 in maths, 25 in chemistry. Okay. So out of 25, like typically like 12 questions will be either from vectors or from calculus, and 13 questions will be from the other one.
Okay, sir. Thank you.
Okay.
Thank you, sir.
Okay,
Thank
people.
you,
All the
sir. Bye,
best.
sir.
Bye. Okay. And if you have any doubts in between while solving questions, you can always send me the question as a picture or a text message on WhatsApp, and I'll help you out with that. Okay.
Thank you, sir.
Okay, sir. Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir. Bye, sir.
Okay. Bye, people.